Okay, folks, welcome back. Today is day 5 in geometry, and we're going to be talking about the distance formula and the midpoint formula for two-dimensional scenarios. In other words, XY axis stuff. We've previously talked about how to find the distance from A to B if it's on a number line. So for instance, say I'm at 0 there, and this is at -3, and this is at 8. How do I find the gap between those two? Let's make it 9. Actually, let's make this point 9 for easier use. How far away are those? Good, 12. How did you do that? Aren't you good? You remember the formula we learned last class, the absolute value of A minus B, where little a is the value at A, and little b is the value at B. And if I take the absolute value of that, of their difference, I get the absolute value of -12, which is 12 units away. Now, if this whole distance is 12, we know that that means that if I were to count it, it would be 12 full spaces. But the question is, what if I have something like this? The point 2,1 and the point 6,4. How far is that? What?
4 and 3.
Yes and no. Those two numbers that you just identified are crucial to us finding the distance. But if you think about it, if you were to walk 4 steps this way and 3 steps this way, yes, you would get there. But do we agree that that's longer than the distance going straight there?
Yeah.
Yeah. So really, we know it's something less than 7. Anyone have any ideas about how we could find this distance? Yeah. Excellent. And honestly, I dislike teaching this particular topic at this point in the year because that's a rule I haven't taught you yet. But how many of you know the Pythagorean theorem that begins with a squared plus b squared equals c squared? Exactly. And what that's used for is to find the missing side in a right triangle. It has to be a right triangle where one of the side lengths is A, another side length is B, and the slanted one, the hypotenuse, is C. So Violet was able to identify that this length is 4. How did she do that? Good. Did she count them, or did she use your tool up here? I'm not sure, but it's going to be 6 minus 2, isn't it? Because those are the x values. And then how long is this? Yeah, the y values go from a big one of 4 to a smaller one of 1. So it's 4 minus 1 is equal to 3, which means that I can find the value of this distance by saying 3 squared plus 4 squared is equal to the distance squared. Now I want d, not d squared. So what do I do to change this back into d? Square root. If I square root one side, I have to square root both sides. Can I distribute this square root across this and just call this 3 plus 4? No. Good. I'm glad you remember that. That means this becomes d is equal to the square root of, what's 3 squared? 9. And 4 squared? 16. Very good. So d is equal to the square root of 25, which is 5. So in other words, when I go from the point 2,1 to 6,4, that length is exactly 5 units. Now, this requires the use of the distance formula in a way, but let's do it explicitly. We're going to now create a formula to find the distance between 2 points. And by formula, I mean it's going to have something where you can just plug in the values. We'll learn soon about this idea of if-then statements. If suggests what the conditions are that we're operating in, then is what we get to say because of that. So if I have a point, I could label it as xy. And then I have another point over here that I'd label also xy. But that's a little confusing to have 2 xy's in the same graph. So I'll call this x with a little subscript of 1 and y with a subscript of 1. And up here, I'll call this x2 and y2. Now I can distinguish between the two coordinates. if I'm looking for this length, D, what I'm going to do is exactly what Violet suggested. I'm going to treat it like a right triangle. And if I know that this comes down vertically, directly vertically, that means this point is x2 and this point is x1. How long is this side? Very good. X2 minus x1. And then how long is this side if up here we're looking at y2 and down here we're looking at y1? Very good. Y2 minus y1. Do I now have a triangle with 3 sides identified? My triangle looks like this. It's a right triangle because this is vertical and this is horizontal, and those are perpendicular to each other, making a right angle. This is y2 minus y1. This is x2 minus x1, and this is D. Since this is a right triangle, I can apply the Pythagorean theorem and say that this part squared plus the other part squared is equal to the third part squared, which is D squared. This one, I'm putting in x2 minus x1. This one, I'm putting in y2 minus y1. And I'm going to now flip these. I'm going to say that if this equals D squared, then D squared is equal to this, x2 minus x1 squared plus y2 minus y1 squared. It's called the symmetric property. We'll learn more about that. But are you all okay with that move? That if 5 equals x, x equals 5, you can flip it. But I don't want D. I don't want D squared. I want D. So what do I do to both sides? Almost square root. That gives me a D on the left and the square root of this on the right. Now, when I introduce the square root, I really should put a plus or minus here because it always gives me 2 possible solutions. Why don't I want a minus here for the distance? Yeah. Good. When we measure a distance, like on a ruler, we always get the positive number. We never want a negative, so we threw out the negative. So this is something called the distance formula. You probably learned this in algebra. You should be able to use it today. It's the way you find the distance between 2 points in a 2-dimensional system, where there's an x component and a y component. In your notes that I've given you for today, I've given you that distance formula, and I'm sorry to say that my printer is not doing what it should do. This looks like a negative sign or a subtraction. It's not. Please change that to a positive. It's the difference of the x's squared plus the difference of the y squared, square rooted. And this is not a negative over here. This is an equal sign. So let's try one. I want to find the distance between these 2 points. Step 1, let's identify that we're going to have an x1 and a y1 and an x2 and a y2. Do you guys want to call this point 1 or point 2? It doesn't matter. 1 sounds great. So this is x1, y1. Let's find out what this point is. Remember that the x is horizontal, the y is vertical. I'm going to the left. That's negative. 1, 2, 3, 4. Looks like -5, +3. And what's point 2? Good. -2, -3. Now I want to apply the distance formula. I want you to write out the formula, because by writing it out, you're going to begin to internalize and memorize it. Once we write it out, we're going to substitute values. So D is equal to the square root of parentheses squared plus parentheses squared. I'm going to subtract the 2 parts that are inside the parentheses. What should I put in for x2? -2. And what should I put in for x1? -5. What should I put in for y2? Good, -3. What should I put in for y1? 3. All right, now we're going to simplify a little bit. When I say -2 minus a -5, what's an easier way to treat that? Good. I'll change this to a positive plus a +5. So now I've got d is equal to the square root of -2 plus 5 is how much? +3 squared plus -3 minus 3, -6 squared. You're at a -3 and you go 3 more negative, it takes you to -6. So that's going to give me the square root of 9 plus, what's -6 squared? 36. Good. Be really careful not to make that a -36. If you lose these parentheses, it'll look like -36. You'll get the square root of a negative number, which would be problematic. So this is the square root of 43. No, 45. And that is the answer. Eventually, we'll learn how to simplify radicals and treat that as 3 square root of 5. We're not there yet. So at this point, I'd like you to be able to, as it says in the top of the notes here, round your answer to the nearest 1/100. So if I take my Apple phone and I turn it sideways in landscape mode, it lets me see a calculator that's more comprehensive. And I want that value. I'm going to have to enter in 45 first, and then come up here to the little symbol with a 2 on the outside of the X showing it's a square root, not a cube root. Hit enter. Now I'm going to copy that value down as my answer. Because it's not exact, I'm not going to write D is equal to this. I'm going to write D is approximately equal to, squiggly equal to. And what would it be if I'm rounding the nearest hundredth? How many did? Yeah, I'm looking at the second decimal back, the 0, and I'm going to check the very next digit. Is it above a 5, rounding this up, or is it below a 5, keeping it as it is? This one's rounding up, so 6.71 would be my distance rounded to the nearest hundredths. Any questions? Please take a moment to find number 2 yourself. Go. Right. Please take a look up on the screen and make sure that your answer for number 2 looks about the same. Ending with a total of the distance is 7.28 units. We don't know if it's inches or meters or miles or centimeters. Any questions on that? Yeah.
A, B, or T.
Either one would work. You're right. It could be A, B is equal to that because that's the distance between A and B. I think that's probably a better answer. All right, we have a total of 3 topics today. This distance formula is one of them. Let's move to the second one. And let's go back to high-level conversation first. Let's say that I give you, again, a number line. And I want you to find the point right in the middle, the midpoint. Where is exactly in the middle of this?
Seven.
You think the point 7's right in the middle? 3 is right in the middle? 6? We're kind of guessing here, aren't we? Positive 3? Okay, how'd you guys find that? Say again? Excellent. So what I just heard was we could find the distance from A to B by doing our formula here, A minus B. And that means it's -3 minus 9 square root, oops, sorry, not square root, -12, which is 12. But that's the whole distance. If we have a midpoint here, we know that that whole distance has been split exactly in half. So it's 6 and 6. And I think I heard somebody say 6 because that's what we initially think of. But what we really want is the coordinate that's 6 units away from 9, and at the same unit, 6 units away from -3. So as it sits, if I add -3 plus 6, I get 3. Or if I take 9 minus 6, I also get 3, telling us this coordinate is 3. Does that ring a bell? Turns out there's a slightly faster way to do that. Watch this. Let's prove it. I'm going to call this point A and this point B. And instead of it doing a pattern of evidence, remember our inductive reasoning, we could do this a second time and do this a third time and do this a fourth time and start to get a handle on how it works. But if we really want to prove it, what we do is we don't choose individual examples. We make it work forever by using variables. So the process you just said was, I'm going to take the distance AB and I'm going to make the absolute value of A minus B. For this problem, I'm going to assume that B is the bigger one and A is the littler one, just so we don't have to worry about the absolute values. And can you agree that the distance is now B minus A? You then said, I'm going to take that distance and cut it in half. So B minus A divided by 2. And then I'm going to add it to A to move in a certain distance. This should be our midpoint. But wait, let's clean this up a little bit. This is a fraction, and this is a whole number. How do I add things with fractions? We need a common denominator. So I'm going to go 2A over 2, right? Multiply by 2 over 2. Now this is something I can combine. Excuse me. So I'm going to say B minus A plus 2A.
You write this down?
Nope. This is a proof of something that you're not held accountable for. If this were honors geometry, yes, I'd hold you accountable for that. You get to ride. So if I've got a negative A and a positive 2A, what happens? Becomes A. In other words, B plus A over 2. Well, that looks easier to work with. In other words, if I want to find the midpoint between these two, I add them up and divide by 2. There's another name for that. What do you call that? Average. Nicely done. So if I wanted to find the midpoint up here, I just could have said the midpoint is equal to 9 plus negative 3 over 2. So 6 over 2, which is the value 3. Easy, right? It's the average, which makes sense. It's right in the middle. Now, in the event that I've got a two-dimensional scenario where this one is like x1 comma y1, and this one appears x2 comma y2, and I want to find the midpoint right in the middle there, I'd like you to visualize this. Just like we did for the distance formula. But now what I'm going to do is recognize that this midpoint here has some x value and it has some y value. If this length is the same as this length, these two triangles will end up being what? The same. So that means this length and this length are the same, which means this length and this length are the same. In other words, this value here is the x version's midpoint. So it'd be x1 plus x2 over 2. It's the average of the x values. What about this y value here? Yeah. y2 plus y1 over 2. It's the average of the y values. So if you want to find the midpoint, all you have to do is recognize that it becomes a coordinate, x comma y, and the x is the first x plus the second x divided by 2, and the comma, the y value is y1 plus y2 over 2. So let's apply that number 4 here. We're going to say that the midpoint is equal to, and again, write the formula out so you get comfortable with it, x1 plus x2 over 2, comma, y1 plus y2 over 2. In this particular case, should we call G point 1 or point 2? It doesn't matter. We could do it either way. Let me create a random generator here. Let's go with Erlin. Pick whether this is 1 or 2, please. It doesn't matter at all. 1, that's 1. So this makes this x1, y1, and x2, y2. I just have to make sure the 1s stay together and the 2s stay together. So now I'm going to say x1, 7, plus 9 over 2, comma, now the y's, negative 5 plus negative 1 over 2. What is 7 plus 9? 16 over 2. And what is negative 5 plus negative 1? Negative 6 over 2. If I take 16 and cut it in half, I get 8. And if I get negative 6 over 2, I get negative 3. So the coordinate 8, negative 3 is my midpoint. Lemon squeezy? Okay, would you please try number 5 yourselves now? Those of you watching the video, pause. Okay, great. So we got a value for this one as we just went over off camera, sorry, of negative 2, comma 0. All right, last piece for today. And then you have the rest of the period to work on the homework. Take a look at problem number 6 here. Read it to yourself first. Okay, how is this problem different than what we just did? Yeah, previously what we did was we had 2 points and we just took their average to find this one. Now what we're saying is, I've got a line segment from here somewhere. If this is the midpoint, what's the point up there? Now, there is an algebraic way to do this, and I can show you that if you wish, but I like to do this visually. So here's what I'm going to recommend. Let's graph this. We know we want a negative 5 for the y and a negative 1 for the x. So I'm just going to graph it like this. I'm going to say negative 1, 2. That's my M point. And 1, 2, 3, 1, 2, 3, 4, 5. The point B is 3 comma negative 5. Now this is saying that AB is the segment and M is in the midpoint. So if I go from B to M and continue up there, do you agree that point A is somewhere up here? Does that look right? So that M is in the middle? And if it's exactly in the middle, then that means I can do what we did earlier, where we draw this little triangle. And if I copied and pasted that little triangle right over here, that would be the same to get up to A. So let's look at the X value first. If this one's 3, and I've got to move back over to negative 1, how many units to the left do I have to move to get there? 4. So in other words, I'm going to do a transition here of negative 4 here, from 3 minus 4 to get to negative 1. What about to go from the Y value, from negative 5 to get up to 2? How far am I going up here? Plus 7. And what I'm suggesting is that this triangle is exactly the same as this triangle. So how far should I go to the left here? Negative 4. And how far should I go up? Plus 7. So if I take my midpoint, and to the X value I subtract 4, negative 1 minus 4 is negative 5. And to my Y value I add 7. 2 plus 7 is 9. That's my point A. What do you think? 5. Okay, visual, a little different, but I can do that. That makes sense to me. 3, it almost made sense. Maybe I just need some practice. 1, I'm so confused by that. Okay, couple of 1s, a lot of 3s, couple of 2s. Let's, how many of you would like an algebraic way? Does that work better? Okay, let me show you the algebra way, and then you decide which way you like it. So what we're saying is that if I'm looking for the midpoint, it's going to end up being in X comma Y, X of the midpoint, Y of the midpoint. And what we're saying is that the formula is X1 plus X2 over 2, comma, Y1 plus Y2 over 2. This is our formula, agreed? But what makes this weird is that the X operates totally independently from the Y. So I have to treat this X with this formula. In other words, the X of the midpoint is equal to X1 plus X2 over 2. And then over here, I'm going to have a different formula. Y of the midpoint is Y1 plus Y2 over 2. And then if I go back and look at this problem, it tells me that M is -1, 2, the midpoint. So if this is -1, comma 2, and it tells me that one of the coordinates, let's call it 0.1, is 3, -5, that means that my X1 is 3, my Y1 is -5, and we don't know these two values, so let's just call them X and Y. Now, again, we have to treat the X's differently. So I'm going to say that the X midpoint, -1, is equal to the X value we've got plus some unknown divided by 2. How do I solve this kind of problem? Yep, cross multiply, and I get -2 is equal to 3 plus X. Subtract 3, and I get -5 is equal to the X value. Then I have to do the same thing over here. What's the Y value of the midpoint? 2, and that's going to be the average of what 2 points? -5 and some unknown Y. Cross multiply, 4 is equal to -5 plus Y. Add 5, 9 is equal to Y. So my coordinate would be -5, comma 9. That's the algebraic way to do it. I think that's long and tedious, don't you? Maybe not. Maybe that works for your brain. I'm going to show you one more time the graphic way here for number 7. Thank you. Okay, so I'm going to look at this. I got a -6, -5. This is a pretty heavy in the negative zone, but let's try it. -6, -8, and 6. This is point L. And -5 and 10. This is point K. And we're looking for JL with K in the middle. So our point is somewhere up there. So if I'm going from a -8 to a -5, how far over am I going? +3. And if I'm going from 6 to 10, how far up am I going? +4. So that means I'm going +3 in the X, +4 in the Y from this midpoint, -5 and 10. If I take the X value of the midpoint and add 3, -2. If I take the Y value of the midpoint and add 4, I get 14. That would be point J. Easier? 5. I can use one of those two techniques to find the missing point if I'm given a midpoint and an endpoint. 3. I'll do some more practice on it and see if it works. 1. That's even more confusing now. Okay, I see a lot of 4s now. A couple of 3s moving up. Okay. That's the extent of what I need to teach you today. What you'll see here is you've got one problem from the first page. Now you've got 4 problems on this page, and then you've got a whole little 2-page document. You do have, what do you have, 30 minutes now to work on the homework? Work on that stuff, finish it up. This is what you'll submit as your homework for day 5. I'll circulate around and help you out.